the stage is yours. A warm welcome to Dominique van Gruisen.
Thank you very much. Is this on? Can anybody hear me? Okay. Good. So thanks for being here, first place, right? And I hope you guys will learn me some new tricks because I'm about to show you some. So last year, there were 2 phone calls that changed my life as I knew it. One was in October or beginning of November when my mother called that my father was dying. So that's the bad news. And one was in June last year when my partner at Innexo called me and he said, hey, with the seed technology company that is within our group of companies, we can do something really cool. You know what we can do? We can sort tomato seeds based on the vitamin C content of the tomatoes that will be produced from these seeds. So we can increase the vitamin C content by 15%. And I knew that they were already working on seed detection, seed phenotyping to eliminate fraud in commercial seed batches. But they went like way beyond that. So what they can do is basically sort seeds through scanning them and sort them on phenotypical or genotypical characteristics. So when I got that phone call, I was driving on the road and I had to pull aside because I had to let that sink in. I was like, this is amazing. If I see that this works on other crops, what would happen to our industry if we could somehow use the same technology, not in tomatoes, not in herbs, not in watermelons, but in cannabis? Is there something there? Little did I know that I was about to open Pandora's box. Because if you see what we've done, it's, I had to, when I saw the results, very honestly, I had to think about that for weeks, what that could possibly mean for the cannabis industry. So I didn't sleep for weeks on end, scratching my head, whether or not to, come forward with this. But as a research organization, I need to come forward with everything that we find that could be interesting to the cannabis industry. So let's get into it. So in terms of cannabis, whether you're a licensed producer or you have nurseries or you're a breeder, everything has a beginning. And the beginning in cannabis, really at the basis, is the seeds. The problem is, it is unpredictable. We all know the stories when we were like home growers. I think many of you still are. You buy 10 seeds, and if you're lucky, 1 or 2 will yield the plant that is advertised on the packaging, right? For me, that was certainly the case. So as we go to medicinal production of cannabis and opening this plant up to regulated medicine in this world, having uncertainty is unacceptable. But today this changes. And I hope you will follow me through the story on how we found out that this technology would work on cannabis. So today we enter a new era of precise and unprecedented control. We can be, with cannabis, in a very short time on par with the regulated seed industry, with normal agri and food crops. And to do this, we'll need quality assurance. No more picking out the white seeds, manual labor or other kinds of separation methods and techniques, but objective quality assurance. What would happen if your producer of the seed isn't able to produce? So he gets some seeds from his other friend and he sells you the seeds that you put into the market. You have no control. Still, most seed companies to this day have no control over what they sell. Let's say you have a rather stable seed line, but there's still once in a while, maybe 1 in 100 or maybe 20 in 1,000 seeds that deliver plants that are not the plants that you would want, so-called off-types. What if we could eliminate that as well? One cool aspect is we looked at sex selection. Can we go from a market that is dominated by females, feminized seeds, can we go and make the step towards all natural females? That's an interesting question, because there's, at least here in Europe, there's a lot of problems associated with feminized seeds, right? If you market your variety, maybe it has won a cannabis cup sometime, somewhere, right? And you know that you sell this variety based on the merits that it won this cannabis cup. Wouldn't you rather really offer this phenotype to your clients that had won the cup? Wouldn't that be cool? Instead of your clients sifting through, uncontrolled seed lots at their own expense? And can we identify very specifically certain traits so that only the plants with a set number of traits be put on the market? Can we do this? Soon we can. I'd like to introduce you to the process of spectral fingerprinting. And, I'm not a spectral fingerprinting expert. I'm just a dummy who used this technology on cannabis for the first time. So no hard questions afterwards. Thank you. So we know that every molecule has a specific absorbance and reflectance of the light that is put on it. And work with other crops has shown that the molecules inside the seed can correlate with genotypical or phenotypical properties. But how to do this? Because if you slice open a seed and you analyze it, it's pretty hard, right? So there needs to be a non-destructive way of looking inside the seed. And luckily, technology has advanced far beyond LED lights that all the growers are using right now. It has advanced to where we have AI, we have statistical modeling, it goes really fast. We have spectral imaging and all that kind of stuff. So what is exactly inside the seeds that we see when we run a seed through the scanning machine? Well, we don't know. That's fundamental research. What we only can do is correlate the signature, the spectral signature of each seed to certain properties. And so this is exactly what we do. So when we can make that correlation, we can identify a trait, we can correlate it with a spectral signature. That means we can spectrally identify something. And if we can identify something, we can sort it out. We can filter it. We can put a filter on it. And this is how we develop IP for our clients, breeders, seed companies, licensed producers, even if they work with F1 hybrid seeds. So the basis of this is a machine that we call the data collector, by lack of a better word, right? So there's 2 machines like this custom built in the world. And one is at our sister company in Venlo, so really near to our location. And this data collector uses an array of different cameras that look on the seed and inside the seed to capture that spectral signature of the molecules that are enclosed within the seed and the embryo. So this is, a rough picture of what all these different cameras can measure. But enough for me talking about this. Let's see how this works. So we have a bunch of seeds that we put on the data collector. The data collector lines them all up and digitally labels each and every individual seed. And I promise you, after this talk, you'll never look at a conveyor belt ever the same. So all these seeds travel along this conveyor belt and they get scanned by different types of cameras. And all this data is collected. And the cool thing is, this is non-destructive. So if we can digitally tag each individual seed, we can blow it into a 48 or 96 well plate, and voila, there's your seed that now has your digital signature combined with a physical location. And this is super important because this allows us to grow out that specific seed. and make annotations on the properties that we are looking for. So when you get to the complete picture, this is how it would look like, right? So you have your X-ray, you look inside the seed, you have your normal visual camera, RGB camera, you look at patterns on the seeds. You know, sometimes you can visually distinguish two different varieties of cannabis just by looking at the marbling pattern on the seeds, for example. We look with chlorophyll fluorescence to see if the embryo is alive, basically. And then we gather a whole bunch of spectral data. So we do not use multispectral cameras for this, we use hyperspectral cameras for this. So we capture each and every single wavelength. That leads to roughly around 5,000 data points per individual seed. So that's a lot of data. But all the data is meaningless if you cannot grow out the plant to check and to correlate. So through the digital tagging, having a physical location, we can manage a grow out and annotation. And I really want to emphasize that this annotation work, this is super important. Because if you make a single mistake, your data will be off, and it's really hard to create a good sorting algorithm. So this is why we do this in-house. So we've developed special software to do this in an efficient way. So because there was not really that kind of software available specifically for cannabis, we just decided to build it, you know, as just a side step. So we gather the data also digitally. This allows us to combine the data and run it through a statistical modeling program that was actually built at the request of those really big seed companies. And I'm not talking about the cannabis seed companies. So using this model, that will allow us to correlate the traits and the spectral signatures. So let's get into the proof of concept that we did. So my question was, okay, this technology is great for watermelons and, you know, tomatoes and grasses and other kind of herbs, but how do we translate this to cannabis? Well, the answer was, you know, pretty easy. Because we have the statistical model, it doesn't care whether it's a tomato or a cannabis plant. So this technology, when it traverses from one crop to another, they do what they call a proof of concept. So they take a certain variety, they look what traits do they want to see, and then run it through the machine, 100 seeds. But this didn't feel right to me for cannabis. I didn't want to just jump into it and claim that, hey, we can do this. No, I wanted to make this hard. So we took a bunch of different varieties, 100 seeds per variety. We did it with 6 varieties, 3 regular varieties, 3 feminized varieties. We looked at intersex. We looked at male-female. We looked at flower color. So there were some purple ones and some half purple ones. And there were related varieties as well there. And so the first camera that it goes through is the X-ray camera. That will basically dictate the uniformity of your seeds through the physical parameters, like seed size in this case, for example. And the closer and the more uniform that they are, the better it is to sort them at a high throughput scale. So when we use the data collector, it's, you know, depending on the seed and what you want to collect as data points, it runs anywhere from 500 to 1,000 seeds an hour. But to get to a commercial sorting scale, we can do 1,000 seeds a minute. And this is when it becomes interesting, because then we can scale this technology up very rapidly. So we don't have to wait for fundamental research. I'm sorry for the university, but, you know. So how does this look? So when we look at the hyperspectral data in the near infrared spectrum, this is one variety, 200 seeds. So every single line represents the hyperspectral data from that specific seed. And you can already clearly see there's different outliers there. But how do these outliers, you know, translate into the traits that we see or do not see? So when the data was being processed by our data analysis, I got a call. And I said, well, Dominic, by any chance, I just want to make sure that we got this right. Have you put out any varieties that are related in some way? First reaction was no. But 5 minutes later, I call him back, say, yes, actually we do. We have two varieties that were, pollinated by the same father. So yeah, there is some relation to it. So then he showed me this. You can clearly see from that spectral signature that the blue and the green varieties are very closely related. And for comparison, we added another genotype, which was more of a broadleaf variety. The other was more like what we call 50-50 hybrid. And it was a clear distinction. So that means literally there's the potential of sorting the seeds from your varieties just by scanning them. Not by growing them out, but just by scanning them. So that's interesting. The second part, off-type detection. Here you see three varieties. One is quite uniform, doesn't really have an off-type phenotype. That's the green line. But the blue and the red ones, they both have off-types. So if we can identify that part and we can sort based on that, we can take out and improve the uniformity of your seed crop. Another low-hanging fruit is how well do your seeds germinate? How long does it take for them to crack open and for the seedling to emerge? Because any day apart means a difference in your harvesting date potentially. And so we looked at different varieties to see whether or not they have potential for upgrading the germination. So if we want for the first variety, for example, if we want to take out all the seeds that pop within 24 hours, we can. Why can we do this? Because we filter out if there's any distinguish between the gray line and the orange line. So we zoom in on a certain bandwidth, and there we put the algorithm to work. With the last variety, for example, the emergence was quite uniform and also quite within the same time, so there is no potential for upgrading this. It's as good as it can be. All seeds emerge like within 24 hours. And then the male-female part. Can we go to natural females? Can we separate out the males and use them specifically for targeted breeding projects? And here's where it became clear to me that it's really variety dependent. Not that we can do it, we can, but the spectral signatures in both varieties look completely different. So here we see the white line. That's all this. That's the signature for the female plants. The blue line is the signature for the male plants. And you don't want to zoom in on the entire signature. You want to identify the peaks that are clearly separable. Another variety that we have done, the male-female, look at the graphs now. First, the male was on top with the previous slide, and now the female's on top. This variety is actually way better suited for sex sorting because the bands are further apart. The further apart the lines on the graph are, that's basically how it works, the better and the more efficient you can sort them. So, would it work on color? Apparently it does. So we had a variety tested, which we knew that we would end up with a small portion of all purple flowers and a phenotype that would have all green flowers and then a bunch of different phenotypes in between. So if my purple phenotype is winning a cannabis cup, I can take that purple phenotype out, sort it, and offer only those seeds to the market. If we look at inflorescence development speed, we all know the plants that are vigorous and do good and they develop their flowers quicker than others. With all three varieties that you see here, we can clearly separate the ones that are slow and the ones that are fast. And if you look closely, let's take, for example, the blue line, the dark blue line, and the orange line. That variety showed around 1 week of difference in harvest date between the different phenotypes. While the other variety, the gray and the yellow line, that was a big difference, well, like 3 weeks difference, different phenotypes. So that's great news because this went beyond the proof of concept that they normally do to translate this technology to other crops. But there's still a long way to go. But we want to put this on the market ASAP. Oh, time is running out, so no more questions. That's great. So the thing is, we do an identification and data collection round. We start building the algorithm. We also do a validation to gauge the accuracy of the algorithm. And only when it's accurate enough, we do the IP and tech transfer. So then you guys can commence high throughput sorting. And with high throughput, I mean 1,000 seeds a minute. Development time to do this, depending on the properties that you're after, is 6 to 12 months. So it's not waiting 10 years for Humboldt University to be done with doing the literature research. No, let's go straight to the action. And on that front, I would like and invite you all to collaborate on this part with us. Because, as I said, this is Pandora's box. So if this technology would get in the wrong hands and companies start developing algorithms for pangenomic traits, then those companies would be the only ones to be able to do this. So what do we offer to the cannabis industry? We offer low cost and low risk pilot programs where we look at germination and sex selection, because that is basically the starting point of quality control. After our clients have run through this first process and they have gotten the confidence that it works on their genetics, we can move up to commercial scale and push their entire library through, so that no single seed of that company is a bad seed that enters the market. And last but not least, I already mentioned it, pangenomic traits. This will really revolutionize the cannabis industry, because if we can find a signature that correlates, for example, with hop-latent viroid, you can eliminate hop-latent viroid from getting into the market at a seed level. Same with tobacco mosaic virus. And another thing, especially for the pharmaceutical companies, we can fast-track the development of placebo cultivars. You know, that 1 in a million that is stubborn and doesn't make any cannabinoids but grows exactly the same as the plant that you've made your medicine from. That's also very, very interesting. So I wanted to end today with saying that actually every seed should be the best seed, and we deserve this as a company. So this was made possible by ourselves, our sister company Innovate Seed Solutions, and our exclusive partner that makes the machine, Secuso. So thank you for your attention. I will take any questions except from Dimi. He cannot ask, Dimi cannot ask any questions. Thank you very much.
That's great. Thank you so much. That was very great. Okay, we have a couple of minutes left for questions. First, I would ask the audience if there are any questions. I think there are plenty. Looking into the crowd. It's not Dimi, it's... Do we have a second mic here? Stefan, you know him already, huh? Yeah. Okay, I give you the mic back.
Yeah, okay. He's gonna grill me, so...
No, it's an easy one. So you say 1,000 seeds per minute, if
yes,
I
sir.
understood?
Yes,
and
sir.
is there a cost around that? So...
Yeah, so if you're doing high throughput sorting, you know, depending on batch size, it may be like 5 to 15 cents per seed.
And what about the cost of doing the R&D, more or less?
The pilot programs are between 10 and 25K for development. And if the further you go, the longer we have to do the grow out and the annotation. So that's where a lot of the costs, the extra costs, are involved in.
But
so,
say you only want to know from a variety, male or female. Would that be...
Well, male or female, that is within our pilot range of projects.
Yeah.
So we engage with our partners to do those projects at cost. Okay. So we don't make any money on it.
So for friends it's free.
Yes. For you it's free.
Oh, thank you.
No more questions. I like that. Do you have a question? Like now you guys feel how I felt for like 5 weeks. So you know, it's but it's like I did this proof of concept because I didn't want this to work on cannabis, because I knew that if it did, imagine doing this on hemp. Hemp is mandatory planted in seed form. So one of these algorithms could be, okay, you take your hemp variety that you use for fiber and for soil decontamination or phytoremediation, optimize for that, you know? So online. Yeah. Who was that?
I don't know. Jonathan is sending me the questions over. Thanks for the amazing speech. Very interesting. With your technique, you would be able to show a lot of frauds from the commercial seed companies. What are your thoughts to this? Do they see this as an offense to their business? Good question.
That's an excellent question. You know, I'm not here to make any friends. You know, that's for sure, right? And I'll probably make a lot less friends than I used to because of this. So this was one of the, you know, the hesitant parts of me, you know, publicly coming out with this new application of technology. And I think for the seed companies and the breeders that are maybe scared, I don't know, you know, but they shouldn't be, because this is a great opportunity to really empower your brand with never before seen quality control. I mean, they have the marketing channels. They are doing a lot of education as well, right? But it's about leading by example. And this is an opportunity that they have right now, right here.
Yeah, I think it's a technology and you can use it on the good and on the bad, like always. It's like CRISPR-Cas, for example. So it's always dependent on the company using it. So yeah, I think we are just in time. If there are not any other questions, thank you so much for the talk. Again, a warm welcome, warm clap to you.